In mathematics, we see patterns all the time. And what we want to look at here is just some of the special patterns that do occur and some special types of numbers that we get from it. The first one is what we call a square number. So if we a square number is, as it says by definition, is one that we can arrange in a square. So one's a square because it's a very simple square. Four looks a bit better because there's your square. So 1, 2, 3, 4. And nine's a square, it can be put in as a square number as well because you've got 3 there and then 3 up, and so there's 9 all up. The next one would be 16. So if you have a look, we can see a pattern forms that the first square number, we get that by multiplying 1 by 1. So the second square number 4, we can get that by multiplying 2 by 2, and you can see there's your 2 there by 2. And the third square number 9 would be 3 given to us by 3. You can see there's 3 along the bottom, 3 along the side, and we say 3 by 3. The next one obviously is 16 because I know it'd be 4 by 4. And then 5 by 5 is 25. So that's the next square number, and so on, and we can keep going. And if you help, it does help to know your square numbers because I know 6. The sixth square number is 36, and the next one's 49, and then 64, and then 81, 100, 121, 144, 169, 196, 225. That's the 15th square number. So you can do, if you understand what the squared numbers are, it's pretty easy to find them. We do have a shorthand way of writing this. Now, we're going to look at this more next week. And what we're looking at here is what we call an index notation. So 3 by 3, we can write a shorthand way of putting it with the little 2 up the top. And that we say that's 3 squared. And that notation basically means to multiply 3 by itself. So we use the term index. So you can also use the word power for that number 2 there, so it can be an index. It also can be called a power, and a big word called exponent, so it can be called that as well. So that's what squared numbers look like. Triangular numbers are ones that, well, obviously from its name again, can be arranged in triangles. 1, 3, 6. So you can see that there's 1 by itself there, 3, so we get a triangle of 3 there, and then we get 6 there. Now how we actually getting those is basically we can see the first number is 1, but then to the 1 we've added 2. So our bottom row is now 2, and the 1 was up the top, so it gives us 1 plus 2 gives us 3. And the third triangular number would be 6 because we're adding a row of 3 down the bottom. Obviously the next one we're going to add on 4, so it would be 10. To get the next one, it would be 15 because we'd have 1 plus 2 plus 3 plus 4 plus 5. So what we do is just basically add up the first however many integers that we've got. So if we want to find the 10th triangular number, we add 1 plus 2 plus 3 plus 4 plus 5 all the way up to 10. So that's how we find triangular numbers. We don't really deal much with triangular numbers. Squared numbers, yeah, we do a lot, but triangular numbers, not so much. So they're not as common as you would see. But you can see that we get them from just getting a nice little pattern of adding integers as we go up. The next one's really important one, and this is called Fibonacci. Now, if you've watched the Da Vinci Code, you would have seen there's a Fibonacci. This Fibonacci series plays a big part in it. If you haven't seen it, have a look at it. It's a really good movie, and it's based around a lot of mathematics and a lot of patterns and things like that and codes. And the Fibonacci series is a really important one. It's one that this guy Leonardo Fibonacci, obviously, in the early thousands, like you can see where he was when he was born, he discovered there was certain patterns that are occurring in nature. So in things like pine cones, in amongst plants and animals and things like that are happening. We'll have a look at a special case in class, but you can, if you want to find out more of applications of the Fibonacci series, do a search on it. It gives you, and will give you lots of different examples of where these things actually exist. It's a really natural occurring type of sequence, and it's a really easy one to find out how to get the terms in the series. Basically what we do, we start with 1, and then the next term in the series is 1. So it's really easy to start off with 1 plus 1. To get the next term in the series, we add them together, which would give us 2. And what we start doing is start adding the previous 2 terms in the series. So if we add 1 plus 2, that would give us the next term 3. 2 plus 3 gives us 5. 3 plus 5 gives us 8. 5 plus 8 gives us 13. 8 plus 13 equals 21. 13 plus 21. And so on. And it keeps going up and up and up. So that's how we find a Fibonacci series. We just start with 1 and 1. So the first 2 terms in the series are 1 and 1. And then we just keep adding two previous terms. And that gives us the next term all the way through. So as I said, we'll have a look at some nice applications and interesting applications throughout the next week, because it's a really, really good series. Pascal's triangle is another interesting one. This was Blaise Pascal was a mathematician who did a lot of work with what we call combinatorics, a lot of counting theorems, a lot of work in probability. So he was actually one of the first ones to prove a lot of things involving probability in games of chance and things like that. And he came up with this nice little application. We use this application a lot in higher levels of mathematics. And basically it's called Pascal's triangle because, as you can see, the numbers are forming a triangle. Our first row, which we call row 0, just for the want of a term, is 1. And then row 1 would be 1 and then 1 again. All the terms on every row starts with 1 and ends in 1. But we start to get our series in row 2 by looking at the 2 terms here, the 2 numbers here. We add them together to give us the number in the middle. So 1 plus 1 is 2. We look at 3 here, that comes from 2 plus 1 is 3. So the same thing here. 4 we get from 1 plus 3. The 6 here we get 3 plus 3, and the 3 plus 1 gives us the 4 there. So you can keep going in the series, and we can find each term in the series really easily if we just go, okay, well, we know the first one's 1. 1 plus 4 would be 5. 4 plus 6 is 10. 6 plus 4, 10. 4 plus 1, 5. And then 1. And if you're starting to notice, well, you might be starting to notice there's some patterns going on that we start to see symmetry. This starts to look very symmetrical. So that's going to be 15. That's going to be 6 and 1. And we can keep going. But if we look at a line of symmetry here, we draw a line right down the middle. We start to see, sorry about that. Let's try that again. We'll see our line there. Our line down the middle here is everything on this side is reflected on everything on this side. So you can see 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So we start to get a nice symmetry about that, and that's very handy when you do aspects of Pascal's triangle and use it in applications. Things like binomial theorem, which you don't do until extension 1, but that uses Pascal's triangle really a lot in it to make life easier. The last one we want to look at is what we call a palindrome. Now, you've probably seen palindromes before, because palindromes are not just numbers, but they are words as well. So dad's a palindrome, okay, and the number 14541. If you watch the video that I put up about with Sheldon from Big Bang Theory, he starts to talk about a number in that video being a palindrome, and he actually states what the palindrome was: 1000100001. So you can see that was a palindrome there, and also he started to talk about factors and things like that. But we can produce palindromes as well. There's a nice little reverse and add as product algorithm we can do to get a palindrome. Say example 17, reverse the digits and add them together. That will give you a palindrome. So what we'll look at is palindromes later on, but really anything that you can see that reads the same forward as it reads backwards is a palindrome. Okay, so whether it's a word, whether it's a number, numbers are nice for us in class, but also if you are doing anything in English or any other thing or any other subject, you can find out palindromes and start to use them as well.